So till this point, we have seen some programming thing and we were able to execute them. We have talked about classes, variable, methods, and object creation as well. Now it's time to actually see what is happening behind the scene. Because if you understand what is happening behind the scene, then the further coding will make sense, right? So every time I introduce a new concept, we can actually relate what is happening behind the scene. Now to understand that, let's focus on some keywords, okay? If you remember, when we started this videos, at the start of the video, I mentioned that to compile the Java code, you need a tool, right? In fact, we have to do setup as well. And that tool is your JDK. Now, JDK here stands for Java Development Kit. Maybe I can just write it here. So basically, why do we need it? Why do we need a development kit? See, the thing is, when you as a programmer, when you type a code, you have to convert that code into bytecode, because ultimately, what runs on the machine is a bytecode. So of course, you cannot type a bytecode. I mean, you can, don't try it, but the idea is you will type the Java code, you will compile it, and it will convert into bytecode, which will run on a machine. But which machine? Now for that, we have one more term here, which is called a JVM. Now basically, JVM stands for Java Virtual Machine. So basically, this is your machine which runs the code. So of course, you have to compile the code with the help of JDK and you have to run the code on JVM. Now, apart from this, there is some more things in the picture. So what happens is, when you want to run your code, so what code I'm talking about the bytecode here. So assuming that you have already compiled and you have a bytecode with you, you need to get a space. Okay, so let's say this is your space where you are going to run your code. And this space is basically your JVM. Now this is where you actually execute the code. Now why it is called JVM is because we have a machine, and to make the Java platform independent, we went for a virtual layer on top of it. So doesn't matter on which machine you have your JVM, it will work. The idea is to have JVM on every machine. Now JVM is going to run your code, and behind the scene computer will convert that into its own way and it will run. So basically, you need a JVM to run your code. But then what happens is, for your code, let's say this is your file here. If this is your file which you want to execute, most of the time, your code is dependent on some external file, not your files which you have created. Maybe you have created 5 files. Apart from the code which you have written, you have used some inbuilt classes, some inbuilt libraries. And that's where we need some extra things here. So maybe we need some extra files from which you are going to use in your code. Okay. Now question arises where you will find all this code. And that's where we have one extra layer here on top of it, which is your JRE. Now JRE stands for Java Runtime Environment. So basically we have a concept of JRE, which is Java Runtime Environment. Now in this JRE, you'll be having all the extra files you need, extra classes, inbuilt classes. It also checks your bytecode. Basically it validates your bytecode. Maybe you want to load a class. So here JRE will help you, but ultimately your code will run on JVM. So JVM is very important because that's where your code runs. But even to run your code, you need some extra files, and that's what JRE will provide you. And the name itself says, right, Java Runtime Environment. So it's an environment where you can run your code. And the beauty is, JVM is a part of JRE. So you can't simply say, hey, we don't need JRE, we need it. If you don't have a JRE, you don't have a JVM, right? So basically, every time when you say you have Java in your machine to run the code, you actually have JRE with it. So you have a JRE, and inside that you have a JVM. But then as a developer, you install JDK, right? Now JDK acts like an upper layer. So every time you install JDK, you also get this too as well. So the top layer here is your JDK. So JDK, when you install JDK, you will get the updated JRE, and also you will get the updated JVM. But by default, on a client machine, you will find JRE and JVM, which will have extra files and which will have where you can run the code. In fact, you might have seen this. Sometime when you install some software, it will say, hey, in this machine, I'm not able to find .NET Framework, or I'm not able to find Java. It's because the software will be running on those particular softwares. I mean, the application will run on .NET platform or on Java. Of course, there are other platforms as well. Just to give an example, we have .NET, Java, and that's why you install extra softwares. The same thing. If you don't have the updated version of JRE, and if you try to run some advanced software, it might not work. And that's why, sometime on Windows, it says Java is getting updated for the same reason, because to support extra the new softwares. So this is basically your JVM, JRE, and JDK. So JDK will have everything, JRE and JVM. And in JVM, you execute the thing. Now, in the next video, we'll try to expand more on JVM. So what happens inside the JVM? Let's see that in the next video.